The handout that I just gave, that's a quiz that you don't have to do right now. The quiz, it's a take-home quiz, and you're going to hand in on Friday. And for this quiz, the question is exactly the same as the example that I did in the class last time. So if you follow the example I did in the class last time, then you will be able to do this problem, okay? Okay, so let me see. Okay, so what we are still in section 10.2, yes. But the topic is different this time. So we are still in section 10.2. The topic today is arc length. The question or the problem that we want to solve today is the following. Let's say I have a curve C, and the curve C is given by x is x of t, and let's say y is y sub t, and let's say t is in a closed and bounded interval from A to B. So t is between A and B. So this is a finite curve in the xy plane, and the question is what's the length? What is the length of the curve C? So let me draw the curve first. So let me make a picture here first. Okay, so here I have the y-axis, this is the x-axis, and let's say the curve looks like the following. You know what, let me make a full page view here. Okay, so let's say this is our curve C. We want to find the length of this curve. So the question is, what would be the definition of length in this case? How do I define the length of the curve C? Okay, and so to see what should be the definition of length, let's think about how we might be approximating the length. let's say right now I only know what's the length of a straight line segment, right? And the question is, how do I approximate the length of this curve? Well, one way to do that is that we can divide the curve into smaller arcs, and then approximate each smaller arc with a straight line segment. So let's do the following. Let's call this point to be P0, and then we can take another point here called that P1, another point here called that P2, and we could keep doing that. And let's say this is the nth point. So I simply picked n different points on the curve, and then so I am looking at the arcs between the consecutive points, right? And each arc I will approximate by, let's say, a straight line segment. So I'm going to join these 2 points. So that's the straight line segment, and this would be another straight line segment. So what we are doing is that each arc between 2 consecutive points is approximated by the line segment between the 2 points. Okay. So the arc between P1 and P2 is approximated by the line segment between P1 and P2, the pink line segment. So I could say that an approximation of the length of C would be what? Well, I could say that the let me call this point number, let me call this Pi minus 1, and let me call this one Pi. So let me say dot dot dot, meaning that you have P1, P2, P3, P4. At some point you have the Pi minus 1 Pi, and then dot dot dot, you have the last one Pn. And so one way I could define the length is that I could look at the distance between the point Pi minus 1 and the Pi. So this symbol means is the length of the line segment between Pi minus 1 and Pi. And then I am going to add up all the lengths of all these line segments. So I have to sum up over I from 1 through n, right? So when I is 1, I get the length between P0 and P1. When I is 2, I get the length between P1 and P2, and I is 3. So if I sum up all this, if I sum up the lengths of all these line segments, I get the total length of the line segments. And I could say that this is an approximation for what? I could say this is an approximation for the length L of the curve C. So let's say L is the length of the curve C. So L here is the length of C. It's the length of C. Everybody is okay with that? So that's one way you would approximate the length of the curve. And of course, so how would I define the length of C then? I see that the bigger n is, the bigger this n is, right? The bigger n is, the better approximation I get, right? Because I will be dividing into smaller and smaller line segments, right? I'll be picking more and more points, so my approximations will get better and better. So that tells me that I should define L, I should define the length of C, L, to be the limit as n gets bigger, right? As n goes to infinity of the sum I going from 1 through n of pi minus 1 and pi. Right? Is it sensible to define the length of C in this way? Okay. Well, that's nice. It's a definition, but I want to know how I can compute this limit. Okay. So everybody is okay so far what we are doing. I simply define what it means to be, what is the meaning of length of a curve. The meaning of length of a curve is this limit. What is this limit? It's giving you the total length of the line segments, right? Everybody's okay with that? The question is now, how do I compute this limit? So in order to compute this limit, let's say that the point P0 is traced at the time t is a, right? Let's say the point Pn is traced at the time t is b. Now let's say P1 is traced when t is t1. P2 is traced when t is t2. Am I making sense? And the pi will be traced when t is what? When t is ti minus 1. Pi is traced when t is ti, and so on. Everybody's okay? And can someone tell me, so let's just concentrate on how to find the length of a one line segment. So I want to try to find the length of this line segment between the pi minus 1 and pi. How do I find this length? Well, in order to find the length between 2 points, I need the coordinates. So what are the coordinates of these 2 points? Well, remember, my coordinate functions are what? My coordinate functions are x of t and y of t, right? So in order to know the coordinates of pi minus 1, what do I have to do? The coordinates of pi minus 1 would be what? The first one would be x evaluated at time ti minus 1, right? And then the second would be y evaluated at ti minus 1. Everybody agrees with that? And what would be the coordinates of pi? Coordinates of pi, the x coordinate would be x of ti. The second coordinate would be y of ti, right? Because the points on the curve are given by x of t and y of t, right? Everybody agrees with that? All right, so if you agree with that, then can someone tell me what's the distance between the 2 points, pi minus 1 and pi? What's the distance between pi minus 1 and pi? How do you find the distance between 2 points? You subtract the x coordinates, square it, subtract the y coordinates, square it, and then add them, take the square root. Okay, so then I could say that the distance between pi minus 1 and pi is given by x of ti minus x of ti minus 1, and then I have to square that, plus y of ti minus y of ti minus 1, and then I have to square that as well, and then I have to take what? I have to take the square root. Everybody is okay so far? All right. Now things get a little bit complicated. Where do I go from here? Well, we are going to apply what is called the mean value theorem. How many of you remember mean value theorem? Okay, the mean value theorem, let's recall mean value theorem. What does it say? Suppose that I have a function f of x. I have a function f of x, and x is between, let's say x is between two numbers, alpha and beta. X is between two numbers, alpha and beta. And the mean value theorem says what? The average rate of change of the function over the interval from alpha to beta, the average rate of change of f, right? As x changes, right? F of x changes, so there is an average rate of change. It says that the average rate of change of f over the interval must be equal to the instantaneous rate of change of f at some point. It's like, think about this in the following way. If you go from Ada to Columbus, and if I say that your average speed was 65 miles per hour, your average speed was 65 miles per hour, then at some point during your drive, your instantaneous speed must have been 65, right? If your average speed was 65, your instantaneous speed at some time must have been 65. And so that's what this is really saying. So what's the average rate of change of f over this interval? What's the average rate of change? Well, what's the change in f over this interval? The change in f is what? F of beta minus f of alpha. That's the change in f over this interval. And then if I divide it by the change in x is what? The change in x is beta minus alpha, right? Everybody's okay? That's the average change in f. And then the average change in f is equal to the instantaneous change, which means the derivative of f at some number c, where c is a number between alpha and beta. So the derivative gives you the instantaneous rate of change of f at some c. So the mean value theorem says that the average rate of change of f over an interval is the same as the instantaneous rate of change of f at some point c in that interval. So we are going to apply this to both functions x of t and y of t. Okay? So apply mean value theorem to x of t for t between ti minus 1 and ti. So if I apply the mean value theorem to x of t for that interval, right, what do I get? What's the average rate of change? The average rate of change of x would be x of ti minus x of ti minus 1, right? And divided by ti minus 1, and that's going to be equal to x prime evaluated at some number ti star. I'm going to call the ti star, where ti star is between ti minus 1 and ti, right? So the average rate of change of x over the interval is the same as the instantaneous rate of change of x at some number in that interval. Everybody is okay with that? What I'm going to do now is is rewrite this by saying this is giving me x of ti minus x of ti minus 1, and that's equal to x prime of ti star multiplied by what? Ti minus 1. I'm going to call that delta t. I'm going to call that delta t, where delta t is this ti minus 1. So I'm just assuming that we divided the interval from a to b into equal subintervals. Okay, so similarly, I can do the same thing to y, right? So similarly, I could say that y sub ti minus y sub ti minus 1 is equal to y prime of si star times delta t. And where delta t is as before, and si star is in the interval just like the other one, this would be si star less than ti here. So what we are going to do is plug these values now in our distance formula. Remember, the distance between pi minus 1 and pi is given by this root quantity, right? Now inside the root quantity I have x of ti minus x of ti minus 1. Here I have y sub ti, y sub t minus 1. We can replace those by what we obtained from mean value theorem. So now what is pi minus what is the distance between pi minus 1 and pi? What's the distance between pi minus 1 and pi now? X of ti minus x of ti minus 1 would be replaced with what? This quantity here. So I get x prime of ti star, and then I have delta t. Now remember that I have to square them, right? Inside the root I square them. So I will have to square this quantity here, and I also have to square the delta t. Same way, the other term in the root was this quantity here, so we can replace it with this. So I get y prime of si star, and I have to square that, times delta t, and I have to square it, and then I have to take the root. Everybody is okay with that? Is that making sense? Now what? Well, delta t squared is a common factor. I'm going to take it outside. So if I factor out delta t, and I also want to take it outside of the root, what are we going to obtain? Delta t outside of the root, right? So what we are going to get then is that this would be x prime of ti star, and then I have to square that, plus y prime of si star. I have to square it, and then I get delta t outside. Finally, remember that we are basically dividing the interval from a to b, right? We are dividing that into subintervals like this: t1, t2, dot dot dot, ti minus 1 and ti, dot dot dot, and this is tn, right? We divided the time interval into smaller subintervals, and assuming that n is pretty big, these subintervals are very small, tiny. So this length that I have here is the same as x prime of ti star square of that plus y prime of ti star square of that, and I get delta t outside. You guys are okay with that? So I'm basically assuming si star and ti star are the same, because I'm saying that the subintervals are too tiny. So then this is the value of pi, the length. This is the length between pi minus 1 and pi. So if I sum over all the values of I get the total length of the line segments. So what's the total length? So what's the sum I going from 1 through n of pi minus 1 and pi? Well, that's going to be equal to what? The sum I going from 1 through n, and we obtained that this is x prime of ti star plus y prime of ti star and then I get delta t. Everybody's okay? Now, can someone tell me, does this look like a Riemann sum? It looks like the Riemann sum of what function? It looks like the Riemann sum of what function? Remember that for a function f of x, right? For a function f of x, what is the Riemann sum of f? A Riemann sum looks like what? Looks like f of ti star times delta t, sum I going from 1 through n, right? You remember that? So this quantity that I have here, this sum here, this is the Riemann sum of what? With what function? That's the Riemann sum of, what's that? What function? So this is the Riemann. Whoops. This is the Riemann sum of the function x prime of t squared plus y prime of t squared and root of that, right? You're evaluating the function at ti star multiplied by delta t, right? Riemann sum is you evaluate the function at ti star multiplied by delta t, right? So that's the function. So this is the Riemann sum of this function, and we know that what's the limit of the Riemann sum? The limit of the Riemann sum is as n goes to infinity. As n goes to infinity, the sum I going from 1 through n of x prime of ti star square of that plus y prime of ti star and the square of that, this sum goes to what? Riemann sums are for what? Integrals. It goes to the integral as t varies from a to b of x prime of t squared plus y prime of t squared square root of that dt. Everybody's okay with that? Yeah. Yes, there was a delta t right here. Okay. And so what we obtained, what we have obtained is the formula for the length of a curve. So if I have so the conclusion is, if I have a curve C, and the curve C has x is x of t, y is y of t, t is between a and b, then the length of this curve is given by the integral from a to b, x prime of t, you have to square that, plus y prime of t, you have to square that, take the square root, and then dt. So that's the formula for the length. Everybody is doing okay. Questions, anyone? No? Okay, so there is another way of obtaining this same formula, but I'll probably show you that next time. But let's use this formula and see how we can find the lengths of given curves. So let's look at our first example. Let's say I have a curve C, and it is x is cosine t, y is sine t, and t is between 0 and 2 pi. Anyone remembers what curve is that? It's the circle, and it is traced how many times? Once. So what would be the length of the curve? What's the length of a circle? It's the circumference. It's a circle of radius 1, so it's 2 pi. 2 pi times r, right? So 2 pi r would be 2 pi 1, which is 2 pi. So the length should be 2 pi. So let's see if our formula gives us the same answer. So by our formula, what's the length? What would be the integral over? 0 to 2 pi. And then I have to take, what's the formula? Inside the root, I have to take the square, the derivative of x, right? What is that? Negative sign, and I have to square that. So I get what? Sine squared of t. And then I have to take the derivative of y. Derivative of y is cosine, and then I have to square that. What do I get? Cosine squared of t. And then what is sine squared plus cosine squared? Very good. So I get 1 dt. And what is that equal to? What's the antiderivative of 1? T. And is that 2 pi? It's 2 pi minus 0, so it's 2 pi. So the length of the circle is indeed 2 pi. So this was an easy example because our integrand simply was 1. Let's look at a little bit more difficult example. Let's say I have the curve C this time, where x is given by e to the t plus e to the minus t, and y is given by 5 minus 2t, and let's say t is between 0 and 3. Okay, so this time what would be the length? The integral will go from 0 to 3. Okay, what is x prime of t? E to the t minus e to the minus t, right? That's the derivative of x, and I have to square that, right? And then plus, what's the derivative of y? Negative 2, so negative 2 squared is 4. So this is what I obtain. And that the integrand doesn't look nice. So let's see what we could do here. Let's just expand the square and see what we get. So expand the square. If I expand the square, what do I get? Do I get e to the power, what do I get? E to the t whole squared, right? So that's got to be 2t. And then what else do I get? I'm going to get 2 times e to the t, e to the negative t, right? And would I get e to the negative 2t? You guys agree with that? If I multiply e to the t minus e to the minus t with itself, that's what I should be getting. Are we okay there? You guys are okay with that? Where did I miss? Oh yes, dt, thank you. dt. Alright, so now what I'm going to do is, you realize that e to the t times e to the negative t is what? E to the t times e to the negative t is, you are going to add the exponents, so you're going to get e to the 0, and e to the 0 is what? 1. So that's just negative 2 then, right? And negative 2, if I add that to 4, that would be positive 2, right? So I'm going to write this as e to the 2t plus 2 plus e to the negative 2t. Now what? Now we need to complete square and get rid of the square root. So can I write what I have inside the root as a square? Can I write that as a square? Remember this formula here. A squared plus 2ab plus b squared is what? It's a plus b squared. You guys agree with that? Well, if I apply that here, notice that what I get here is 0 to 3. This is e to the t squared, right? Plus 2 times e to the t, e to the negative t. I'm rewriting 2 as that. And then this is e to the negative t squared. And then that quantity is equal to what? I can write this as a square, right? What is that square? Yeah, e to the t plus e to the negative t squared dt. I forgot dt right here. And now I can get rid of the root. So I have e to the t plus e to the negative t dt. And finally, what's the antiderivative of e to the t? E to the t, right? And what's the antiderivative of e to the negative t? Negative e to the negative t. That's the antiderivative of e to the negative t. And then I go from 0 to 3. Yeah. The 4 you're talking about right here? Yeah, the 4 was added to 2. See, e to the t, e to the negative t, that's 1, so I get a negative 2 plus a 4. Yeah. So basically, the quantity inside became e to the t plus e to the negative t. And this is what we obtain. And now what? We plug in 3 and 0, right? If I plug in 3, what do I get? E to the 3 minus e to the minus 3. And then minus, I'm going to plug in 0. E to the 0 minus e to the 0, right? So what do I get? E to the 0 minus e to the 0, right? That's just 1 minus 1. Everybody is okay with that? Any questions so far? Okay, I am going to stop right here. Next time we will do more on this arc length. Yeah, you couldn't take the exam today, you said?
I couldn't take the exam because I have practice at 3 in the day.
And then tomorrow?
Tomorrow I have class from 12 to 1:15, but I can come at 1:15 directly following that class.
Yeah,
or whenever it's available.
Why don't you come tomorrow at 1:30?
1:30? Alright, sounds good. Thank you so much.
The results in the conclusion.
Why don't you go ahead and wait at my office?
So, I mean, I made it like a lot. That's really
Is that like see you tomorrow?
okay.
Yeah, let's see.